All right, so for whatever reason, I did not make a video for the practice test on our geometry measurements test, and some people have been asking for it to help them review so they can retake it, or maybe kids have missed a couple of days. So the one suggestion that I will make is make sure you have your formula sheet filled out and bring it with you if you're trying to do this review or the test, because it has all the formulas on it. So find the midpoint of the line segment. We learned that to find the midpoint, we're finding the average of the x values and the average of the y values. So I'm adding, to find the average, you add things together and divide it by the number of values. So that's my x1 plus x2 divided by 2. And then y1 plus y2 divided by 2. So 4 minus 3 is 1. And 1 divided by 2 is a half. And 4 plus 4 is 8, and half of 8 is 4. So this here is your answer. It should be an ordered pair. So same idea here. x1, y1, x2, y2. I'm finding the average of those x values. And over here, to find the y, let's add those together. So negative 4 divided by 2. So that is my answer. It's an ordered pair. I think the most questions were asked about this one. It gives you the midpoint. Right? It gives me the answer. I have the answer, but that's not what it's asking. It wants you to find the other end point. So we have x1, y1. We don't have x2, y2. So we set it up just exactly the same. The average of the x's equals the midpoint x value. The average of the y's give you the midpoint y value. How do I solve this? Well, I need to get rid of this 2. So I'm going to do inverse operations. And let's move the 6 over. I've run out of room. X equals negative 14. I'm just going to write it up above. Okay, same idea over here. Let's multiply both sides by 2. Let's get rid of that 1. I've run out of room again. So my y2, my other endpoint, so negative 14, negative 11. I really wish I had my answer key sitting in front of me to make sure I'm doing these exactly right, because I'm going kind of fast. Okay, once again, they've given me this midpoint. They gave it to me. What I'm missing is x2 and y2. Oops. And you solve it the same as this one over here on the left. So let's multiply both sides by 2. Subtract 5 from both sides. Multiply both sides by 2. 0 plus x is x. So here is that answer. So negative 16, negative 1. I feel like I'm being so sloppy. That is the other end point. And here, negative 14, negative 11 is the other end point. Did I put these in a nice box? Yes. 1/2, 4, and negative 1/2, negative 2 are the midpoint. All right, distance formula. This is derived from the Pythagorean theorem. I really hope you have it in your notes. I like to label them x1 and y1, and x2 and y2 because the formula, and I will write it down, x x2 minus x1 squared. That's like a squared. This will be like b squared. y2 minus y1 squared. So once I have them labeled, this should be as simple. Even though it's a lot happening, you can plug into your calculator a ginormous square root symbol, parentheses. My x2 is negative 2 minus 7 squared. And then I put my y2, which I've labeled that the negative 4, minus y1 squared. Plug that whole thing into your calculator, press enter, and voila, we're going to round to the nearest tenth, I think it says. So 12.7, that's the distance between those 2 points. Same idea here, x1, y1, x2, y2. Let's plug that in. So x2 is negative 8 minus x1, which is another negative 8, square that difference. Y2 minus y1. Oh, I just remembered this problem. Those are the same point. How far away is the same point? Did anybody else get this far before realizing there's going to be 0 units apart? I promise on your test they are not 0 units apart. So maybe it was worth going through all of that. Negative 8 plus 8 is 0. 0 squared plus 0 squared. The distance between them is 0. Okay. You could find the ordered pair and use the distance formula. I do not recommend that. I would suggest you create a right triangle and use the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. And c is that diagonal line. So I've got 1 plus 25 equals c squared. I don't want to know c squared. I want to know c. So what's the inverse operation to get rid of that guy? I hope you're thinking this right in your head. The square root, of course. And the square root of 26 is 5.1. We are estimating, we rounded to the nearest tenth. I would do the same thing here. Some kids were doing like negative 3, 4. I just wouldn't do that. I would count 1, 2, 3, 4, 5. 1, 2, 3. Use the Pythagorean theorem. A squared plus b squared equals c squared, where c is that diagonal line that they want us to find the distance between. All right, I found c squared. I don't want c squared, I want c. So we can do the inverse operation. It'll be approximately 5.8 units apart. Okay, this has some very involved directions. Create a right triangle. Hey, why isn't it working? 2, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, done. Create a right triangle. Find the length of all the sides. We're pretty close. 2 squared plus 4 squared equals c squared, where c is that diagonal line. 2 squared is 4. 4 squared is 16. We know now to take the square root of both sides. This one said to round to the nearest tenth, so I'm going to call this 4.5. Let's go over to this one. 4 squared plus 6 squared equals c squared. I don't want c squared. I want c. The inverse operation is to take the square root. So 7.2 is about what c equals. Find the length of all sides. Check. Calculate the perimeter and round to the nearest tenth. Okay, perimeter is all the way around the edge. So 4.5 plus 4 plus 2. And if it asked you to find the area, I feel like the test asks for the area. You do 1/2 2 times 4, which is 4 units squared. I know it didn't ask for the area, so it only asked for the perimeter. Okay, let's look at the other one. The perimeter is the measure all around the edge, which is 17.2 units. You have to put units or I will mark it partially wrong. Okay, find the area and the circumference. Oh, maybe this is the one I was thinking of that asked for two things. So we've got to find both the area and the circumference, which is like the perimeter. So if you look at your formula sheet, the area is pi r squared, but the circumference is 2 pi r. So just be super careful that you use the right formula. So the area is going to be pi 2 squared, which is 12.6 inches squared. And the circumference will be 2 pi r. And 4 pi is 12.6 inches. Whoa, they're both 12.6, which is really weird. But this one is square units, which fills the whole thing in. And this one is just like a measurement, like a measuring tape. Okay, I think the hardest thing about this one is they did not give you the radius, and you need the radius for area and circumference. So the radius is just 10. It's just half of that 20. So pi times 10 squared is 314.2 kilometers squared, and your area will be 20 pi, which is 62.8 kilometers. So check and check. So we have lots of different formulas. Parallelogram might seem like it's something tricky because with these dashed lines, it feels like a triangle kind of deal. But it's not. I don't know if you can picture, but if you splice these two pieces together, it makes a rectangle. So we just do base times height. And it is square units because it's area. Base times height. Square units because it is area, meaning I could fill it up with 50 little squares. Base times height. Units squared, it's area. Okay, trapezoid. What? It should be on your formula sheet. We need to find the average of the two bases. Remember, to find the average of something, like we did with the midpoint, we add the values together. Since we're adding two values together, you can divide it by 2, and then you multiply that by the height, and it's the straight down from the top at 90 degrees. So it's not these slant heights. We don't use those for the area. So this one's 57.96. Oh, round to the nearest tenth. Ooh. What is happening? My sleeve is drying. Okay, one more side. Volume. Volume is 3 dimensions. So when I'm done, this should be kilometers cubed. This should be yards cubed. All right, what is this? Well, it's a rectangular pyramid. Any pyramids will take that 1/3 length, width, height. And so this one, interestingly enough, is a whole number. This is a rectangular prism, not a pyramid, but a prism. So I don't need the 1/3. Length, width, height. It's kind of funny when there's two of the same numbers. So 810 yards cubed. All right, we've got a sphere. Kind of fun to say that. A sphere. Which has a really weird fraction. And we cube the radius. It's got to be 3 dimensions. Something times something times something. So 4/3 pi 4 cubed is 268.1 yards to the power of 3. Don't forget to the power of 3. Cylinder, pi r squared times the height. It's kind of laying on its side. So the 11 is my height. They do give me the radius. And this one ends up being 1,693.3 kilometers to the power of 3, 3 dimensions. All right, another rectangular prism. So length, width, height. 10 times 11 times 12. Let's find another fun color. This looks fun. Okay, 1,000. Oh, you can't even see it. Can y'all see it? So light. 1,320 centimeters cubed, cubic centimeters. I better change colors. That was way too light. I ran out of fun colors. All right. This one is a cone. Anytime you come up to this point, it feels like we're using a 1/3 pi r squared times the height. They did give us the radius. They said it was a 3. They gave us the height. They said it was 11. So this one was 103.7 inches cubed. All right, hopefully that helps for any of you that were needing to review again, to retake it, or maybe you just weren't here. I know there was a couple kids sick the whole week before this.